Hello again, folks. Today we're going to be talking about and tearing down this Symbol CS1504 laser barcode scanner. And these were most recently predominantly used by market research companies. You might remember back in the day when somebody used to come round to your house and ask if you bought, Kellogg's cornflakes or the shop's own brand cornflakes, those kind of questions. But that's not cost effective to do anymore. They used to have to pay them a wage, obviously. They used to have to pay their travel expenses, pay for accommodation if they were working in an area not local to them. And that is a massive cost when you think of that type of market research being done in a national level. So it became more cost effective to send you one of these types of devices, a fairly modern device. This is probably about 8 years old, maybe something like that. But yeah, relatively expensive, but more cost effective to send this directly to you, the consumer, to conduct a market research for them. And of course, what you would do would be you'd be walking around your supermarket, doing your shopping, scanning the barcodes for the products you were purchasing that day, and when you get home, you'd upload that data to their website, and they would then resell it to the supermarkets, essentially getting you to do the donkey work for them. And of course, they would incentivize that by giving you high street shopping vouchers, or cash or a check, or money off coupons, that kind of thing, for you essentially doing their donkey work. But these things, as modern as they are rapidly becoming obsolete. And the reason for that is these things, which I'm sure you've got in your wallet, store cards. And when you register for a store card, again, you're incentivized to do so by getting money off vouchers or cardholder specific offers or exclusive offers. And when you register for them, you give them all your personal details, your name, your address, your date of birth, how many children you've got, X, Y, and Z. You give them the lot. And then when you scan your shopping through the self-checkout or even a manned checkout, the last thing before you pay is always, have you scanned your store card? Yeah, and when you do, that links the shopping you've just purchased, along with what time you purchased it, what type of products you've bought, do you buy offers, X, Y, and Z. Again, they've got everything linked to you, the consumer, with all your personal details. And, as a first-hand example, just the other week there, a couple of days before my birthday, I scanned my matching more card in Morrison's, and the printer printed out a coupon saying, happy birthday, Chris, have a bar of our super duper luxury chocolate on us. So they know everything about you. I know it's not quite Big Brother, but I mean, I suppose if you wanted to go down that route, who's to say in a couple of years when you scan your card, it doesn't take a picture of you at the checkout and see who you're shopping with. Are you shopping with children, or are you wearing a leopard print onesie at 3:30 in the morning in Tesco's or something like that? A little bit far fetched. Mine's a zebra print. Obviously, joking, and I digress. But yeah, these are rapidly becoming obsolete, and you can pick them up fairly cheaply on eBay. I got this one for around £10, including delivery, and it comes with the unit itself, a mini B to 9-pin D serial plug, and a USB to 9-pin serial COM port adapter, so essentially to add a serial port to your computer. Now, I have actually successfully used this with Windows 10, which took a little bit of effort. The most modern driver, which was installed by Windows automatically, would not allow the device to start, and I had to randomly roll back to a driver from 2008, so an 8-year-old driver, to get it to work in Windows 10. But I have managed to do that. Now, why have I bought this piece of obsolete equipment? Well, firstly, I thought it'd be quite interesting to tear down and have a look inside. But secondly, I like listening to music, and I've got quite a large collection of CDs and vinyl, getting into the sort of thousands, and not suffering from OCD, thankfully. They're all in a completely random order in the shelf, in no way arranged. And I quite like to sit down and listen to music, and read through the booklet and look at the artwork and all that stuff. I know it's a bit old fashioned, but that's what I like to do. I like having MP3s and iPods and all that good stuff. But yeah, CDs and vinyl's my thing. And what my intention was was to go through each of my shelves of music and scan the barcodes of them all, put them into a spreadsheet, and using the wonders of the internet, from the barcode data, pull down the artist title, so the artist name and the album title, put it into a searchable spreadsheet. So if I want to listen to, say, I don't know, Beatles, Sgt. Pepper's Lonely Hearts Club Band, I can type that into the spreadsheet and it will tell me it's on shelf 4 or whatever shelf it may be on. So whether I ever get round to doing that, I don't know. But yeah, that's one of the reasons I bought it. So without further ado, we'll have a look round the unit. A fairly pleasant looking device, quite ergonomic in design. It's got a little LED indicator up here, as you can see, bi-colour, red and green. We've got our plus, which is a scan button, and a small minus, which is essentially a delete button. So if we scan something twice, or we decide to put something back in the shelf, we can take that off by pressing the minus button. On the left hand side, we've got our mini B socket, and then at the business end, we've got the lens on the end with an aperture for the laser light to come out. And you can probably just see that sort of curved lens, slightly blue in colour, with the coating. That's the sensor. And then if I just do it, you can see it there scanning. And it is an actual scanning laser, scanner. So without further ado, we'll have a look inside. Now, the difference between this and the previous barcode scanner I showed you, which was a USB based CCD device, is that this unit does not directly connect to the computer. This actually stores 150 barcodes, whereas the USB based one is detected as a human interface device. That's to say, it operates essentially as a keyboard. So when you scan the barcode, it sends a text string to your document, be it word processing or a spreadsheet. It'll actually send the text directly into the document, whereas this, you have to scan your barcodes, connect to the computer, and then dump as one lot of data. It's got 4 SR44s, which are AG13 equivalent if you prefer. And of course the scanning technology in this, let's say this uses a laser to scan the barcode. The CCD essentially uses a primitive camera, but it ultimately both have a sensor, a linear sensor that detects the reflected red light from the white sections of the barcode. Hopefully it should be obvious that the black of the barcode will absorb the laser energy and not reflect back. And then based on the reflections, it will decode that and then give you your sort of alphanumeric data, or numeric data. So, going to open this up. I'm expecting it to be fairly simple. Possibly just one package, although I might be wrong. But yeah, we'll have a look inside. Okay, and I am wrong. But first of all, the top cover, we can see it's one piece of rubber for both the buttons and the light guide for the bi-colour LED. And then looking at the actual PCB itself, we've got the LED there, small surface mount device, a few capacitors, looks like a crystal there. It's like 3 sort of rotary switches. I don't think they're potentiometers because they've got numbers around the edge, so those are probably just sort of rotary and not encoders, but multi-way switches. And 2 tactile switches for the scan and delete functions. Now, I have no idea what any of these chipsets are. We can see there's a Texas Instruments there. I think that's Fairchild. We've got a microchip package there as well. And a few of them. I'm not sure what manufacturer uses that logo. But there's various packages on there. Now, clearly, some of that will be for the serial interface, but I don't know what other packages are for, maybe power management and other such like things. Anyways, if we go to the other side now, we've got a piezo speaker for the beep function, and we've got this rather large quad flat pack. I'm not sure what the manufacturer is, but that's probably got all the software to run the scanning and I would imagine there may be an element of storage in there, unless one of these small packages is the storage. Ultimately, it can store a maximum of 150 barcodes, so it's more than likely that one of these small packages is just the memory for that tiny amount of information. We've got our two battery connectors which are implemented direct onto the board, and we've got a little rubber shroud around the USB connection, and that's probably just to offer support when it's in the case. But of course the exciting bit is the laser. Yeah, so how that works is, I don't know if we can see, if you just look in there you may just be able to see a sort of circle with a slot in it, and what that is that's going to focus the laser energy coming out the laser diode here. So that's coming out 90 degrees to the mirror, and the mirror is mounted on this white sort of cam, if you like, this piece of plastic here. And what will be on there will be the mirror, obviously, and there'll be a magnet on the back which will be oscillated using this coil here. So the circuitry will put an oscillating signal into the coil, which will in turn react with the magnetic field of the magnet on this piece of plastic, and you know, oscillate the mirror, thus scanning the LED light which is coming out the front, which will check the barcode, and then the reflected laser energy will enter this the sensor via this lens at the front, and then will then be decoded and stored. So fairly straightforward operation, really. So what we'll do is we'll try and power this off. Oh, sorry, power this on using the bench supply. So if I just set to 6 volts, a couple hundred milliamps, that should be fine. Now what I will need to do, and I should have thought about this beforehand, is a bit crude, but I'm going to use this piece of cardboard here to insulate the other side of the board, because I'm using crocodile clips, and of course we could fry the unit, you know, if we're shot on the other side. Okay, so I'll just put the output of the supply on, and then we can see it in operation. So if I press the button, you can see the that line of laser energy coming out, so this way. So there's a sort of vertical slot, and that's hitting the mirror, which you can see is oscillating. And I've just noticed something which I'll come back to in a second, which might be quite interesting. But yeah, that's oscillating the mirror and then projecting, as you can see, the laser light out the front of the unit. It's a bit strange that it's seems to have a space in the middle, but there we go. So we can see it's scanning. We'll see how far away we can do that. So that's a good maybe 15 or 18 centimeters away, and we'll try and see what's the angle it can detect at as well. So that's I don't know how obvious that is from the camera, but that's probably about 70, maybe 80 degrees from the actual aperture. That's actually a really impressive detection range. I suppose Symbol are probably the market leaders in barcode scanning technology, so you'd expect it to be a fairly high quality product, which indeed it would appear to be. So yeah, works quite well. Now, the thing I said that was interesting, I don't know if you heard the noise when I put my screwdriver close to when I was pointing out the laser, but this is a magnetized screwdriver, and of course it's a low voltage or a low power device, so it will require very little sort of voltage and current to operate the coil that oscillates the mirror. And the fact that this screwdriver is magnetized, if you just watch the little white plastic cam just to the left of this black plastic piece, if I bring my screwdriver in, you will see that is causing the mirror to move, and that's purely because the magnetic field generated by the tip is reacting with the magnetic field of the magnet attached to the mirror assembly there. So that's pretty much it. I thought it'd be quite interesting to tear down. I I've been trying to think of other uses for this. Of course, it can only really be used for scanning barcodes, but I just wondered if there's anything else we can actually use it for, to implement something that would make everyday life a bit easier. Of course, you do get barcode scanning apps with mobile phones nowadays and stuff like that. So, I mean, we could essentially use it for scanning barcodes for products as we use them. You know, for instance, if you're having baked beans with your supper, you could scan the can, and then when you're going to do a shop, just download your scanner and it will tell you the products you need to replace. I suppose that's one option, but again, like I say, that could probably be very easily implemented using an app on a smartphone these days. But yeah, I just thought it'd be quite interesting to tear down. If you've any thoughts or comments, please leave them below. Yeah, as always, if you enjoyed the video, please like and subscribe. Until next time, take care of yourselves and all the best. Cheers.